When we look at this cosine and sine equation, to solve for this is very difficult because we have a mix of cos and sine functions. And furthermore, we have this 2x in here, but this isn't a problem because this 2x is the same here and here. So the angle that we're actually solving for is going to be 2x, and it's the same in both cases. The real issue is we have a cosine here and we have a sine here. Well, we can't solve for cosine and sine at the same time. So what we have to do is first use an identity. And we're going to convert that cosine into a sine using the Pythagorean identity. So I'm going to first start with that cosine. So I have 2. And then instead of cosine, I'm going to use 1 minus sine. Okay, and it works because it's sine squared and cosine squared. We have an identity. We don't have an identity to convert cos to sine, but we have an identity to convert cos squared into sine squared, which is what I've done here. So I've applied the Pythagorean identity to this expression, and I've now converted it into a sine expression. So now at least we have everything in terms of sine, okay, which now allows me to rearrange this into a quadratic equation. So this is a quadratic equation in terms of sine. So I need to first of all rearrange this into a quadratic equation to be able to solve it. So I'm going to expand. And I'm going to put the coefficient of 2, that negative, I'm going to make it positive because I don't like it as negative. Because since we're being asked for exact values, we're going to have to factor this and find some special angles to solve this. So I'm going to put everything to the right-hand side. I get positive 2 sine squared 2x plus sine 2x. And then it's going to be plus 1 on the left side, so it should be minus 1 on the right-hand side. Okay, so when I combine, just so that, let's make sure we know where these pieces are coming from, that 2 and that minus 1 on the left side become that minus 1 on the right-hand side. Okay, so now I can factor this. So I'm going to factor this. So these are relatively easy to factor because there's really not much choice. I know it has to be 2 sine x and it has to be plus minus 1 for the last term because that's the only way we get minus 1. But we can always just do it more formally. We have 2x squared minus 1. We know that the diagonal product is negative 2. We know it adds to positive. The middle is positive, so we get like that. So it's going to be 2x, and this is going to be minus here. So it's going to be 2x minus 1 and x plus 1. So 2 sine 2x minus 1. And then it's going to be sine 2x plus 1. Okay, so I've now factored that. So solving for sine, so we know that sine 2x is equal to positive 1/2. Here we have sine 2x is equal to negative 1. So looking on my circle, I know that sine is equal to positive 1/2. That is a 30-degree angle. So we know it's going to be in these two positions. Okay, so that's going to be our positive 1 over 2. This is going to be our positive 1 over 2 in this quadrant. So the 2x angle and our theta 1 is going to be the quadrant 1. So that's going to be pi over 6. Okay, and then solving for x, we get pi over 12. So we then solve for the second angle, quadrant 2 angle. I'm going to label theta 2, and I'm going to maybe highlight these. Okay, so this one is our theta 1. That's going to be that angle. And then this angle in here is going to be this theta 2 angle here that I'm solving for now. Okay, so this theta 2 is going to be 5 pi over 6. So the x is then equal to 5 pi over 12. Okay, so I have two solutions here. We're going to talk about the period in a bit, but I'm going to solve for the other one first. So I get 2x. So sine is equal to -1. Well, sine is equal to -1 down at the bottom. There's only one place for that. Okay, so I have only one solution in one period for this. And this is going to be at 3 pi over 2. So the angle is going to be 3 pi over 4. Okay, so that represents my last angle here. So I have three solutions in one period. Now, this doesn't state to solve for all real values, but if it's just one period, this is one period. If it's from 0 to 2 pi, well, the period in this case, I'm just going to write it over here, the period, or the t value, is actually equal to pi because of that horizontal compression of 2x. So that means if I want to find 0 to 2 pi, I'd have to have two sets of solutions. Okay, so now if this was all real numbers, we still would use that period of 2 pi, and we would do plus n pi for each solution because we know that these solutions are going to repeat every period. And this represents solutions for all real numbers. So I'm going to highlight that. So there's plus n pi. That's to do with solutions for all real numbers.